Hello everyone, myself I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss the topic of encapsulating security payload. So coming to the overview of this encapsulating security payload, we should know what is meant by ESP and what are the modes of ESP, working of ESP process, and what are the advantages of ESP and disadvantages of encapsulating security payload. So first one, what is meant by encapsulating security payload? So we need to know of all encryption services in the Internet Protocol security services. So it is nothing but it provides all encryption services in IP security, that is mainly depends upon the integrity. So integrity is nothing but the data should not be modified or it should not be altered for the payload and not for the IP header, confidentiality and the authentication. So basically these three that using the encryption process, without this authentication it should be strongly discouraged because it is insecure. So without these three, it should be an insecure process. Any translations in readable message format into an unreadable format are encrypted. So they are going to use it to hide the message. That is the main task of the ESP, and it also provides an open framework such as SHA and MD5, that is a secure hash algorithm and message diversion of version 5. So basically they are implementing with the industry standard algorithms. So of this industry standard algorithms, it will use as an unique identifier for each of the packet, so which is data equivalent for the fingerprints and also checks for the packets whether it is should be authorized or not. And there are some of the characteristics which are associated with the IP security process. So we have seen in the previous slide of frameworks such as SHA and MD5. So that are the standardized algorithms which are present in IP security are SHA and MD5 process. It is also one type of characteristics, and it identifies every packet and also authentication is carried out based on the verifying process. So such that this IP network or IP security has an security payload present of the security purposes. The next one is modes of ESP. So in ESP it consists of, it supports two kinds of modes. One is transport mode and also the tunnel mode. So already we have seen in the previous of authentication header also consists of two modes. One is tunnel mode and also the transport mode. Let us see here in the encapsulating security payload also having the two modes. One is transport mode and also the tunnel mode. So what will happen in this tunnel mode and also the transport mode? So let us see, first one is tunnel mode. What is this tunnel mode? So it is basically, it is mandatory in the gateway process. It basically holds utmost importance. So this always holds and it is mandatory in the gateway process also. When a new IP header is created, which is used as the IP header followed by the ESP. In tunnel mode, one is mandatory in the gateway and another one is outer IP header. Then second one is transport mode. So in this transport mode, the IP header is not protected via encryption or authentication, so making it vulnerable to threats. That is the main in the transport mode. So here the IP header is not protected either encryption or the authentication, so message can seen visibly. So like that it can make and it will be vulnerable to the some of the threats. So it is also less processing is seen in this mode. So the inclusion of the ESP should be preferred. So we need, it is not secure, so we are performing as an security payloads of encapsulation. So how it is going to be work? The working of the encapsulating security payload. So it both supports both main network layer protocols, that is nothing but an IP version of 4 and IP version of 6 protocols. So it performs the function of encryption in the headers of Internet Protocol, or it performs in the IP header. Two main things, one is Internet Protocol and another one is IP header. So, and one more important thing is to insertion of ESP between the Internet Protocol and other protocols such as UDP, TCP and also the ICMP protocols. These are the three protocols which will happen between the Internet Protocol and IP header. These are the two services which should perform functions in the IP header and also the internet protocols. So basically what will happen in this important point is also basically the insertion of ESP should be done between internet protocols and also other protocols like UDP and TCP and ICMP protocols also should be based on the working process. So let us see how it is going to be work in the consist of an ESP. So here consists of security parameters. It consists of the sequence numbers, and it also how the payload data should be considered and what are the padding. So padding is consists of an padding length, and the next header process. The next one is authentication data. These are the working process and steps of the ESP. So let us see first one of this diagrammatic. It consists of the components. First we can see security parameter. The security parameter always consists of the size of 32 bits, and it is mandatory for the ESP to both the links and also the associations. That is the security parameter which is assigned to the size of 32, and it also maintained to mandatory to security parameter. The next one is sequence number. In the sequence number, it also consists in 32 bits of the size and works as an incremental counter, not as an decremental. It should be always increases. And this first packet has to be an sequence number of 1 assigned to SA. That is nothing but an security associations. Means always it purpose to the security purposes. The next one is payload data. What will happen in this payload data? So payload data should not have any fixed size and variables in size to use. So basically it refers to the any data or that provided by the method of the encryption process. So it does not have any fixed sizes and are also variable in size to use the process. The next one is padding. So basically this padding has an initial size of 0 to 255 bytes assigned to the working process of the ESP. So this padding is sent to be securely fits into an cipher block only, not as an plain text block, it in the cipher block correctly. So padding it consists of then 0 to 255 bytes and it should be fits into the cipher block correctly. The next one is padding length. So what is this padding length happens? It always consists of the size of 8 bits to use, and it also measures the pad bytes whether it is preceding or not. The next one is next header. So this next header is also associated with the kind of the pad length with the 8 bit size to use, and it also determines the data type of payload by studying the first header of the payload services. So basically it runs with the 8 bits and also responsible to the data type of payload by studying of the first header of the payload, not last of the header, first header of the payload. The next one is authentication data. So this authentication data is also be variable and never fixed for the use case, and also it is an optional field that is applicable when security associations are selected. So mainly it serves as the purpose of providing integrity services. So basically in the authentication we are going to use only the integrity. Means the data should not be any modifications or should not be altered by using the authentication data. So of all these types of 7, we have seen of the security parameter and sequence number. Of all this we are using the sizes of variable sizes, how they are going to be used with the encryption process. So we have seen with the security parameter and sequence number of the consist of 32 bits. We need to remember the main points of security parameter is 32 bits. Sequence number is also 32 bits in size, and always the sequence should number 1, and this payload also does not have a fixed size, and this padding length should consist of 0 to 255 bytes, and it should not secures into the cipher block only. So this pad length and the next header also fixed size of 8 bits to use, and also the authentication data is variable and never fixed for the use case, and mainly it provides the integrity purposes. The next, what are the advantages of ESP? So encapsulating security payload, it also mainly contains of the advantages is nothing but it provides the security, and it also maintains secure gateway for the data transmission or the message transmission purposes, and it basically authenticating the origin of the data properly or not, and it provides needed data integrity, and it maintains the data confidentiality also, and next it helps the anti-replay services by using the authentication header. So advantages is nothing but an having of main purpose of the ESP. We know that ESP consists of the three methods. There is a confidentiality, authenticity and also the integrity. So of these three messages, it is nothing but a advantages of ESP. The next one is disadvantages of ESP. So what is the disadvantages? It consists of the two modes of the disadvantages. One is there is a restriction on the encryption method to be used, and also global use and implementation. It consists of mainly weaker encryptions are mandatory to use. That are the main disadvantages in the ESP formats. So one is encryption method to be used of the restriction process, and also the weaker encryptions are mandatory to use. That are the two variants of the disadvantages. So in today's session, we have discussed with the encapsulating security payload. In the next session, we will discuss about the combining security association process. Thank you.